We're calibrating the TEAC 3340S reel-to-reel. We're going to begin with the output levels on channels 1 through 4. I've adjusted channels 2 and 4 already. These are the outer boards. And then when you let these down, the identical boards are located beneath here. And we're going to adjust channels 1 and 3. And we're adjusting it with the output knobs set to maximum. And we're going to measure the output signal of this tape. So the reading on the multimeter will read, I think it's plus 6 volts. Yeah, plus 6 dB at the output jacks. Right now I still have them connected to channels 2 and 4. I'm going to move them up to channels 1 and 3. And we'll check them one at a time. And this is just a 400 hertz tone at 0 dB. And when we have these knobs set to maximum, we should read plus 6 dB on the meter. I have this set for so the 0 reference line will be plus 10. So we're going to look for minus 4. We're going to adjust the potentiometers to read minus 4 dB at the meter. Okay, we'll start with the right channel. Little high, so we'll bring it down to negative 4 dB, and that'll equate to a plus 6 on the output. Rewind the tape a little bit, and we'll check the left channel. It's a little high as well, so we'll bring it down. Okay. So now all 4 channels are set to the right output levels. The next step is to adjust the output levels by adjusting these knobs, bringing them down to where they read 0 dB on the multimeter. Before we were looking for plus 6 dB. Now we want to reduce the levels of the output to where we actually read 0 dB. I've done the first 2 channels 1 and 3 already. Next we're going to adjust channels 2 and 4. We'll start with channel 2. That's the white wire here. So we'll just press play, and we'll adjust the left channel for 0 dB. And I've changed the setting, so we're going to read 0 dB at this point here. Okay, and we just bring it down until it reaches 0 dB. Sensitive. Okay. And we'll rewind the tape a little bit and check the right channel. And we'll adjust channel. This is going to be channel 4. Okay, and then we're just going to drop it down to 0 dB again. Okay, and all four of these channels should be at approximately the 2 o'clock position. Yeah, that's what this one is. That one's okay, and they're all in pretty much the same position. So we're not going to mess with these anymore. This is the reference that we're going to be using for the rest of our testing. So the output levels will stay where they are. Next, we're going to adjust the VU meters to read 0 dB at the position the output knobs are set for the 0 dB output we read on the meter earlier. I've done the first one already. Just reading 0 dB. Now we'll do channels 3, 2, and 4. 1 and 3 are located beneath this board on this board. So I'll finish up with channel 3 and then we'll close this up and we'll do channels 2 and 4. We'll close this up for a second. And then we'll work on channels 2 and 4, setting those guys for 0 dB at the meter. And we'll finish up with channel 4. Okay, now all 4 channels are set at 0 dB when the output knobs are set at approximately 2 o'clock position. Next, we'll be doing the minimum input level setting adjustment. That calls for a negative 18 dB signal to be generated at the oscillator. This is our negative 10 dB reading, so subtract another 8 from that, and that's the negative 18 dB signal. And we're going to send a 400 hertz tone. It's 40 times 10, so that's a 400 hertz tone that we're going to be sending into the machine. And what we're going to look for is what we're going to adjust is these 2 potentiometers for the left and the right channels. I've done them on channels 2 and 4. So when we have that negative 18 dB input, we'll adjust these potentiometers for 0 dB as the line input controls are set to maximum. Okay, and we're going to monitor that reading on our multimeter. We're going to switch it from the oscillator to the input signal and drop it down to where the reference line is 0 dB here. So right now this signal is a little high, so we're going to bring that down. This is the right channel, so that should be this guy. we'll monitor the okay. Okay, so that's with the other one. And we're going to crank it down to 0 dB. We'll get as close as we can. It's kind of sensitive. Okay, and next we'll do the left channel. Because that was the one I did earlier, so I got it way out of adjustment. We'll have to bring it back up to 0 dB. Okay, so now all 4 channels are set for 0 dB when they have the neg 18 dB signal going into the machine and the line input knobs set to maximum. Okay, I just finished up the minimum line level adjustments on the unit, and they're set for 0 dB when you have a negative 18 dB signal going into the to the unit. Okay, and using the oscillator on this record test set, we'll see that this is the negative 10 line, and when we go all the way down to here, that equals neg 18. And then when we monitor what's coming out of the tape deck, it should read 0 dB. So we'll change the scale so 0 dB reads at this 0 here, and then we'll monitor the output of the tape deck. It should go up and rest at the 0 dB, and it does. That's the left channel, and we'll do these individually. And then this is the right channel, and it should be 0 dB as well. A little bit north of dB, but that's not a big deal. You can always adjust these guys to make a minor changes on the right channel, so you can bring it down a little bit if you like. But the important thing is you want the knobs to be in virtually the same position on all 4 channels to reach the 0 dB level. And once you've got it adjusted on the output, then you have to adjust the VU meter so they read 0 dB also. And this is channel 2 and 4. We can see that those read 0 dB. And I'll change the inputs up to channels 1 and 3. Okay. All right, that's the input we're checking. And I have to change the output because they're still connected to channels 2 and 4. So we'll change the first one, and this is the other channel on the, okay. And we should read it right at 0 dB. Okay, that's the right channel. And we'll change it over to the left channel. It should read 0 dB also. And if we check the VU meters, they've been calibrated to read 0 dB as well. And again, that's with the negative 18 dB signal at the input. Get a better read on that with the lower reading. And that's neg 18. Next, we're going to use the same TEAC test tape to check the alignment of the playback heads. Okay, this represents the left and right channels. When we add these two signals together, we should get a 45-degree angle. And that's a fairly stable signal, and that indicates that the playback head is in alignment. And since the channels 1 and 3 are in alignment, we'll assume that channels 2 and 4, tracks 2 and 4, are also in alignment, since they're all located on the same head. And the next step we'll do is check the record head alignment, and we're going to look for that same 45-degree angle on the playback head after it's recorded the signal from the oscillator. Okay, our next step is to monitor the, to check the alignment on the record head. We're using an oscillator to send a 400 hertz tone to the unit. And this is actually this will be the input of the unit, and this is the output, what's actually been recorded. We're going to add those two signals together and make sure we still have that 45-degree angle we had observed earlier. And that's a good signal. A little fluctuation, that's common with any analog tape. If it were out of alignment, then we'd see a signal like this. Right now I'm just moving the tape with my finger. If that record head was out of alignment, we'd get some kind of crazy signal like this. But this one's in good alignment, so we're in good shape with this one.